The function shows growth or decay depending on what the base is. So if you have f of x equals b to the x, this value right here, it depends. If b is greater than 1, it's growth. And if b is less than 1 and greater than 0, then it's decay. The graph of a growth exponential function is going to look something like this. And the graph of a decay exponential function is going to look something like this. To view this problem, we first need to create a table. And so what they've done is they've given us some values to use. So we plug in -2 for x, and when we take 1/2 to the -2 power, remember that that switches the numerator and the denominator and makes the exponent positive. So we get 2 over 1 squared. So this ends up being 4. Then we plug in -1, and the same thing's going to happen again. We have 1/2 to the -1 power equals 2 over 1 to the first power, so that equals 2. Then we're going to use 0, and then when we take 1/2 to the 0 power, well, anything to the 0 power is going to be 1. And then we have 1, so we have 1/2 to the first power, which is 1/2. And then our last value is, we plug in 2, and we get 1/2 to the second power, and that equals 1/4. So now we have our table of values. So now what we want to do is graph it. So we have -2, 4, -1, 2, 0, 1, 1.5, and 2 1/4. And then what we want to do is connect it. And make sure we put arrows and realize we're getting really close to 0 here. Y equals 0, but we're not quite touching. And that completes the problem. The first thing we want to do in this problem is we want to graph the function. And in order to graph the function, we need to list the table of values. Now, this is a linear function, and the easiest way to do this is to find whole values of x. And so what I did is I picked -10. -10 minus 2 is -12, divided by 6 is -2. The next value I looked at was -4. -4 minus 2 is -6, divided by 6 is -1. And then we always want to look at 0, what's happening at 0. And so we get -1/3. Our next value is 8. And 8 minus 2 is 6. 6 divided by 6 is 1. And then what we want to do is we want to graph these points. So we got -10, 2, -4, -1. 0 1/3, 8 and 1. And so then we want to draw our line. and this is f of x. Then it tells us to find the inverse of the function. Well, the easiest way to find the inverse is to set y equals to x minus 2 divided by 6. Switch to x and y, so then you get x equals y minus 2 divided by 6. And now we're solving for y, so you multiply by 6 on both sides, you get 6x equals y minus 2. Add 2 to both sides, and you get y equals 6x plus 2. So our inverse of our original function is 6x plus 2. Now, what we can do is, if with the inverse, we can go ahead and graph this. We know we're at positive 2, and we go up 1, 2, 3, 4, 5, 6 over 1, and down 1, 1, 2, 3, 4, 5, 6 over 1. And so here we have our line. And this is the inverse. Now, if we didn't want to find the inverse this way, we could also look at the inverse by simply switching our x and y values. So negative 2, negative 10, negative 1, negative 4, negative 1/3, 0, and 1, and 8. And as you'll see, these points, negative 2, negative 10 is on our graph, negative 1, negative 4 on our graph, 0 and a third, or excuse me, negative and a third, and 0 is right about here. So we're off a little bit, but that's mostly because my graph is off. And then 1, 8 is up here, and that's also on our graph. Now, the last thing that we want to do is we want to state the domain and the range of each function. So when we look at the domain of our inverse here, as we go in the positive x direction, our x value gets bigger and bigger and doesn't stop. And as we go in the negative direction, x keeps getting smaller and smaller. So it's going to be negative infinity, positive infinity. And our range, as we go up in this direction, it keeps getting positive, and as we go down, it keeps going negative. So this is negative infinity, positive infinity. And this is what we would expect with lines. And the same is true for the function itself. The domain is going to be negative infinity, positive infinity, and the range is going to be negative infinity and positive